really want to make these short so that you can kind of binge watch them. This book should clarify your questions about the electron volt. And I'm going to start by asking a simple question. Given that E equals hf for a photon, how many photons of red light, 700 nanometers, would it take to transmit an energy of 1 joule? Try it on your calculator now. I'll give you a few seconds, and then tell me what the answer should be. Well, let's work that out. If I calculate the energy of one red light photon at 700 nanometers, so that is hc over lambda, that's the energy of my photon. And then if I want a joule, that means I need to just take 1 joule and divide it by that number, and that will tell me how many photons will make up that 1 joule. So 1 joule, 1 measly little joule, that's the equivalent of taking about 1/4 of a gram of water, maybe what's left sloshing around the bottom of my coffee cup, and heating it up by 1 degree. It's not a lot of energy, and yet there's about 3 times 10 to the 18 photons transmit that 1 joule. Photons are really small. So simple question, is the joule really a sensible unit for talking about photon energies? Obviously, no. There's a much better one, and it's really sensible, this unit, when you understand it. I'm just going to tell you what it is for now, and then I'll tell you where it comes from. The electron volt is the energy gained by a single electron which is accelerated through a PD of 1 volt. I can work out, using the basic equations from electricity, how much energy this is. In lesson, I would just get you to work it out. So again, I'm going to give you a few seconds now to pause the video, and you can work out just how much energy is transferred to the charge of 1 electron accelerated through a PD of 1 volt. Did you work it out? The equation from electricity is V equals W over Q. Potential difference is energy per unit charge. So if I take the potential difference, which is 1 volt, and I multiply it by the charge, which is 1 electron, then I get 1 times E equals the amount of energy. The amount of energy, I don't even need to work out. It's 1.6 times 10 to the minus 19, because that's what E is. And so actually converting between electron volts and joules is actually quite good. We don't need to remember any new constants. We don't need to remember any different numbers. The conversion factor is just E, the charge on an electron. So try it for this red light. If one of those red light photons carries some tiny amount of energy, how many electron volts is that? Take the joules, divide it by E. So that's a nice, quick, easy summary of the electron volt. 1 electron volt is the energy required to accelerate an electron through a potential difference of 1 volt. Put it on your flashcards, learn it as a definition. How do I actually use it though? Well, to get from joules to electron volts, you know that the number is going to go from something very small to something which is kind of an everyday size. So you divide it by E. To get from electron volts to joules, you multiply it by E, the charge on an electron. It's dead easy, and I know you'll be sat there watching this video thinking, what the hell, Rob? That means that you need to do some of the questions at the back of the book, and you'll soon realise, oh, right, it is really easy, I get it. Electron volts don't go away. They're used over the next 3 books. They're used in Module 5. They're used in Module 6. When we're looking at the interface of electronics and photons, the electron volt is dead handy because we can just use it in electronics calculations as well. But don't worry about that until we get on to kind of Unit 5 and 6. That's all for this week. Photons is a really short book. You'll find from the exercises as well that it's really straightforward. Do your revision pages. That's what the rest of this week is for. If you go and DOS off and don't do them now, then you'll be the one who is stressed out in year 13 and who is struggling. And you'll be the one where you come into support and say, Rob, I really don't understand waves. And I will say, where are your revision pages? For everyone else, this is why we're going to be so much better than everyone else sitting the physics exams next year, because you're doing them now and I don't even really need to ask you. Keep on doing what you're doing. Try the little exercises on photons and waves, and next week we're going to look at evidence. Why photons? But they're not waves. How do we know? That is next week with the photoelectric effect.